Hello students, this is the second part of the previous video and welcome you to the online class of Swami Vivekananda Institute of Science and Technology. This is the second video of the interpretation of the iron carbon diagram. So in the previous video we have already drawn this iron carbon diagram and I have explained that how to draw the iron carbon diagram in a very easy manner. Okay, anybody can draw it. If you have any doubt, you can ask me question afterwards. You can email me directly or you can put your question in the comment box. No problem about it. I will try my level best to answer your calls. So anyway, let us continue over here. So in the previous video, I have shown you that what are the different lines, what are the different individual points and what are the pure phases that we will see in the iron carbon diagram. For example, over here, this is pure liquid phase, pure delta or delta ferrite phase which is appeared over here, pure austenite or gamma phase and pure alpha ferrite phase that we have shown over here. And also in the right hand side at 6.67% of carbon, that is pure cementite or Fe3C, that also I have shown over here. So let us continue from here itself. So how to interpret this one? So first of all we have to identify that what are the intermediate phases or metastable phases that appeared in the iron carbon diagram. First of all, over here individually, if I can show you that, you will find out that at the top it is not a pure triangle but it looks somewhat like that. This is one of the phases that appeared where pure delta phase is at one side and liquid at one side. So what is inside this particular region? That is the combination of these two. So this means delta plus liquid or liquid plus delta, whatever you like, you can write, both are correct. Similarly, the inverted triangular shape which you will find over here. This is the inverted triangular shape which you will find over here. What is beside these two? One of them is pure phase, that is delta ferrite, and the other one over here, that is austenite. So it is a combination of these two, that is delta plus austenite. So inside this, that is delta plus gamma or austenite. Similarly, over here, the entire space which you can see, it is in between austenite and liquid. So from here, this is gamma plus liquid. What about this one? This one is cementite and liquid, L plus Fe3C. Coming over here, this is pure alpha or alpha ferrite that we know, and this is austenite. So this particular triangular or similar to triangular type of thing look like shark fin. It is called shark fin curve. So this shark fin curve which you can see over here, it consists of this particular thing. It consists of over here, it consists of left hand side alpha, right hand side austenite. So it consists of alpha plus gamma. That's all. So over here, what you can see in this shark fin type of region, we have seen that is a combination of alpha ferrite and gamma. So what is there in this particular region which is below and above 727 degree line and below 1147 degree line? That is very important, that we are going to interpret and we'll try to understand right now. But before that, you must know that from 0 degree to 2 degree or approximately 2 degree percent of carbon, this region is called as the region of steel, and from 2 degree to 4% of carbon, that is called as cast iron region. So this part is for steel region, this part is for cast iron region. Then from 4% to 6.67%, what it is called? Is it cast iron again? Yes. That is technically you can call it cast iron, but that is industrially that is of no use, because over here we can control, we can modify the internal morphology, structure, grain boundary, grain structure, grain size, and all the heat treatment process and all other things that we have got 100% control from 2% to 4%. This type of thing that is called as cast iron. There are 4 types of cast iron known, that is ductile cast iron, that is malleable cast iron, grey cast iron, and white cast iron. But from 4% to 6%, that is so much irregularities are there, so we don't have much control over it. So it is not possible for us to consider this portion for any industrial or any particular specific application. We don't have any control over it. So that is why it is not generally used, commonly it is not used. Okay, that is only used for some experimental purpose and scientific purpose, that's all. So anyway, this particular point, and there is another point over here, this point, 3 points are very important, remember. So first one, at this top, if I observe it clearly, it somewhat look like this. Over here, there is one solid. Over here, it is producing another solid. Over here, it is producing some other type of solid, and it is producing liquid plus solid. Okay, remember what I am telling? I repeat once again. So you are getting some inverted type of curve at this particular point, okay, above which what is there? It is a combination of what? It is alpha plus gamma, that is gamma austenite. So S1 plus S2 you will find out above this line, and it is producing a particular type of solid over here. We can call it, what is there in this particular thing, that is gamma plus alpha. So it is producing S2 plus S3. Okay, below it one particular type of solid, and at the right side it is producing liquid plus another type of solid. This type of reaction is very common in terms of peritectic. So it is called a peritectic reaction, and it is called a peritectic point. Okay. Now coming to this particular thing, over here you just invert this curve, so it will look like this. Over here it is liquid at this point, and here it is liquid plus a particular type of solid and liquid plus another type of solid. So it is liquid plus S1, it is liquid plus S2. And below, what it is producing? It is producing actually S1 plus S2. It is producing. So this thing over here, it is producing third type of solid of different property. This point is called as eutectic point. Okay, and this one, from solid to solid conversion is going on. Over here, similar pattern. By the way, I am writing down the name. It is called as eutectic point. And over here, what we are getting, that is called as eutectoid point. So in eutectoid point, instead of liquid, one particular solid is dissociated with multiple type of solids, so with different properties obviously, and different phases and different orientation, different microstructure, different crystal lattice. So these all things when happen, then it is called as eutectoid point. So we are getting peritectic point, eutectic point, and eutectoid point. And remember one thing, that at eutectic point, this vertical line which I have drawn over here, this is the line of Ledéburite. Okay, remember this name. And the vertical line I have drawn from the eutectoid point, this is the line of Pearlite. Okay. Now we can give suppose if I just remove these names only. Suppose it is denoted by L and this is denoted by P on that line. On that line, Okay, not right hand side, not left hand side. So what is there? Left hand side, and what is there in the right hand side in this rectangular region? What do you think? So it will be L plus Fe3C. Anything else? No, not really. But actually there will be there. I will tell you. In the left hand side, that is ledebutyrite plus gamma plus Fe3C. And in the left hand side, that will be gamma plus Fe3C. So this region, it contains austenite plus cementite. This rectangular region contains ledebutyrite plus austenite plus cementite, and this region, it contains ledebutyrite plus cementite. Remember this thing. This is very important. Now, if I okay, so let us continue. If I consider this rectangular region, and this one, what are there? So we already know that if we are considering the line of perlite or line of ledebutyrite, anything above is called as hyper, anything below is called as hypo. So when it is hyper ledebutyitic, then it contains L plus Fe3C. When it is hypo ledebutyitic, then L plus gamma plus Fe3C. Similarly, over here, just perlite. So perlite, it will be P plus Fe3C over here. What about left hand side? That is alpha plus P. Simple in this steel region. Now, if we go downward of this cast iron region, or the region which is just crossing the cast iron region, then it will be P plus L plus Fe3C. It will be P plus L means ledebutyrite, not liquid, don't get confused, plus Fe3C. So that's all. So this is the interpretation of phase diagram and identification of different phases, especially that appeared during the cooling process from pure liquid state to room temperature at different percentage of carbon containing within it. That's all. Thank you very much. See you soon.